Assalamu alaikum, my dear students. I hope you will be fine. Operation research to integer linear programming, and the first type is Gomarys cutting plane method. First question is given, and today discuss this question. Maximization of an objective function z is equal to x1 plus 4x2 and such that 2x1 plus 4x2 is less than equivalent to 7. 5x1 plus 3x2 is less than equivalent to 5. x1 plus x1 x2 is greater than equivalent to 0. This is the simplex method. But to add that x1 and x2 are integers, this is Gomarys plane method. The standard form, convert into standard form and introduce the slack variable. Introduce slack variable s1 and s2. Basics -1 -4 and s1 s2 is 0 solution. s1 2 4 1 0 7 5 3 0 1 15. Okay, the function is optimal. It is not optimal because the 0 r is negative. The most negative coefficient is -4. x2 is entering variable. And to find the minimum ratio test, 7 divided by 4 and 15 divided by 3. The minimum ratio is s1. s1 is the living variable. Next, to apply the row operation and to convert one and the other are zeros. -4 and 3 convert into zeros. Multiply 1 over 4 and to convert 1. -4 plus 4 and new pivot row, -3 new pivot row. Operation applied for all of the functions. It is to check this function is not optimal because the 0 are positive. x2 is equal to 7 over 4, x1 is 0 and z is equivalent to 7. But it is an integer. Step number 2. Solution is not integer and go to step number 3. x2 is equal to 7 over 4 and this written as that integral part plus fractional part. Okay, 4 plus 3 7 over 4. This can be written as integral part plus fractional part. Constants related that x2 is 1 over 2 x1 plus x2 plus 1 over 4 s1 is equal to 7 over 4. Zero plus 1 over 2, 0 plus 1 over 4 s1 is equal to 1 plus 3 over 4. Choose the fractional cut related to x2. x2 is equal to 1 over 2 x1 plus 1 over s1 is equal to 3 over 4. Only use the fractional part, not integral part. This can is greater than equivalent to 0. -1 over 2 x1 -1 over x1 multiplying on both sides. This can be constants are less than is equal to -3 over 4. This can be written to standard form plus y is equal to -3 over 4. And the previous table and add 1 y1 is adding for this table. Z, x2, s2 and y1. x1, x2, s1, s2, y1 and solution system. This can that -1 over 2 x1, x2 is 0, s1 is -4 over 4, -1 over 4, s2 is 0, y is 1 and solution is -3 over 4. Done. Next, to check that this function is not optimal. y1 is the living variable. y1 is the living variable. हम यहाँ पे dual simplex method को यूज़ कर रहे हैं. y1 is the living variable. Entering variable that minimum of -1 over 2 divided by 1 mod -1 over 4 divided by 1 mod is equal to minimum of 2 4 mod negative value to convert into positive value. Minimum is 2. x1 is the entering variable. Next to that, convert that x1 is replaced by y1 and y1 is replaced by z, x2, s2 and x1. and minus 1 over 2 multiply 1 over 2, and to convert into the new pivot row, and all the other minus 1 new pivot row, minus 1 over 2 new pivot row, minus 7 over 2 new pivot row, and to convert this table that. Next, to check that this system is an optimal solution. It is an optimal solution. X1 is equal to 3 over 2, x2 is equal to 1, and z is equal to 11 over 2. Solution is not integer. And go to step number 3. Repeat this. Step number 3. X1 is that. X1 and x2 check it that. So x1 is not integer. x2 is an integer. First x1 that 3 over 2, 1 plus 1 over 2, 2 plus 1. To convert into integral part plus fractional part, the constants are x1, 1 over 2 s1 minus 2 y1 is equal to 1 plus 1 over 2, and this constants can be written as that x1 0 plus 1 over 2 s1 minus 2 y1 plus 1 over 2. Only use the fractional part. 1 over 2 s1 1 over 2 just, and multiply on both sides by minus. Constants are changed. Minus 1 over 2 s1 plus y2 is equal to minus 1 over 2, and the new table are according to changing this table that y2, x1 x2 s1 s2 y1 y2 solution. y2 is that minus 1 over 2 s1 only, and plus 1 equal to minus 1 over 2. It is not feasible solution. It is not feasible solution. Minimum of minus 1 over 2 divided by 1 over 2 mod. S1 is the entering variable. S1 is the entering variable. Basics z, x2, s2, x1 and y2 convert into s1. Lim variable is y2. Next, convert that minus 1 over 2 multiply 1 over 2 new pivot row, and apply these operation minus 1 over 2 new pivot row plus 5 over 2 new pivot row minus 1 over 2 new pivot row, and to convert all the zeros are applied and all the row operations are applied, and this is that. x1 is equal to 1, x2 is equal to 1. All the solution is integer, and x1 is equal to 1, x2 is equal to 1 and z is equal to 5. This is the complete questions of the Gomarys cutting plane method. Okay. Please like and subscribe my channel.